Today you will hear from a range of presenters who are doing exciting work in the field of sustainable buildings. This is, I think everybody will agree, a most important topic that affects all of us. After all, climate change and energy security are two of the most urgent challenges that we are facing today.
For many years, NYPA has been a leader in energy efficiency advancement and the development of renewable energy technologies. Since the 1980s, the Power Authority has helped to promote a cleaner environment, save taxpayer money, and support the reliability of the state's electric system by reducing energy demand. Last year alone, NYPA's energy efficiency efforts cut energy demand by 10 megawatts, lowered the annual energy bills of public facilities by approximately 9 million, and reduced greenhouse gas emissions by nearly 36,000 tons. We completed energy efficiency and clean energy projects at 156 public facilities during the year, while continuing to pursue 416 additional projects statewide, multi-year projects.
Human beings are consuming this much energy. And this is what we're predicted to be producing in relationship to this by 2050. These are the other examples of all the renewable resources along this little crescent curve. Here's wind. This is some sort of an ocean tidal energy technology. This is biomass, hydro, geothermal, tides, and again, all this compared to solar. These are all renewable resources, though, that we get on a regular, ongoing basis all the time. Over here, we have our finite resources. I'm interested in you seeing the concept going on, the difference between the solar resource and these other energy sources which are going to run out. And this is approximately right now, if all of these different areas just put in 3.3 terawatts each of solar power, it would take care of all the energy needs of the world. When you see the financial people backing these kind of systems, that's when you know that it's time.
In passive house, low and deep energy retrofits, zero energy houses, the devil really is in the details. You can do a great job designing an R50 wall and do a terrible job designing the connection between the wall and the roof or the wall and the slab and increase your heat demand by 30 or 40% because you messed up the connection. This is, I don't mean to toot my own horn, but this is exceptionally low air leakage. To my knowledge, this is the tightest a house in New York City has ever, house or building has ever been built to. I feel pretty confident in saying that. This was the first certified passive house building in New York City. We got our certification a couple weeks ago. Even though it was a retrofit, we hit the passive house new construction standard, which is lower air tightness and lower heating and primary energy demand. So I think we did a damn good job.
Simulation models where we represent occupants and building operators in their typical behaviors for a given building design. And so we hook up our human agent submodel to the standard tools of the trade like Radiance for lighting and Energy Plus for energy performance simulation, and end up being able to simulate building performance in a way that reflects realistically, more realistically, how a building occupied by real occupants, operated by real operators, is likely to perform.
It's a nice example of a very large joint in a facade in Germany. It's a 2-inch joint. So they use 2 tapes on top of each other in order to bridge that gap. And it's been around for 8 years and no issue at all. And a very nice learning as well was that was not the main purpose, because they did it twice before with cork and it always came out, so it didn't stay in the joint. So the third time it was done with this tape, and after quite a while Hannah was approached by the company in this building, and they said, well, a very nice side effect is that the energy consumption was lowered by 50% because the joints are huge and there was always leaking before.
And this is what it's all about. When we build buildings, well, it's about us. It's about human beings in that building, and we want to feel comfortable.
The more airtight the building is, the more high performance it's going to be, and the more you can control it. So that is where we're coming from as a company. We talked about the Passive House standard of 0.6 for new buildings. The retrofit standard is at 1. These are sort of unheard of airtightness standards for the American market. In Germany, they can do 0.6 now with their eyes closed and their hands tied behind their back. It's very easy. And when you talk to American construction in general, they think it's absurd that you're asking to go to 0.6.
The Das Haus Pavilion itself is a mobile exhibition pavilion demonstrating renewable energy and energy efficiency technology from Germany. The project, as I had mentioned earlier, is being conducted here in the US and in Canada as part of the German-Canadian Chamber Network, as well as the German-American Chamber of Commerce Network. It's on a 12-city North American tour right now through the US and Canada. White Plains is stop number 9, so we're sort of wrapping up some of the last couple legs of the tour. The project is fully supported by 2 federal ministries of the German government, as well as the government's export initiatives in renewable energy, as well as energy efficiency technology. Thank you.